Hello students, welcome back to Narayana Digital Classes. Today we will be solving the assignment number 28 on the topic atomic structure. Let's move on to the assignment. Here the first question, the orbital having electrons with quantum numbers dash are called 3D orbitals, right? So they have given orbitals, we need to assign the quantum numbers to this particular orbital, right? So the orbital is 3D orbital. Orbital is 3D orbital. So in this any particular orbital, the number indicates the principal quantum number. Principal quantum number. So the principal quantum number represent with small n. So we can say that small n equal to 3, right? And that orbital symbol, the d orbital symbol represents the azimuthal quantum number. Azimuthal quantum number. So the azimuthal quantum number represent with small l. So each and every orbital contain different numbers which represents the azimuthal quantum number. For example, if there is s orbital, the l equal to 0, p orbital l equal to 1, for d orbital l equal to 2, and f orbital l equal to 3. So each and every orbital contain different azimuthal quantum numbers. So that what is the d orbital's azimuthal quantum number? That is 2. So principal quantum number n equal to 3 and azimuthal quantum number l equal to 2. So the correct answer is second option. Let's move on to the next question. Here the question, the shape of d orbital. We know that each and every atom contain different types of orbitals. In that orbitals the electrons are present, right? So we know that there are 4 types of orbital: s orbital, p orbital, and d orbital, f orbital. So each and every orbital contain different shapes. It represents the different shape. So s orbital is in spherical and p orbital dumbbell shape. And d orbital have double dumbbell shape. Double dumbbell shape. So the correct answer is first option. Let's move on to the next question. Here the question is dash orbital lies between x and y, right? So we know that orbitals, atoms contain different kinds of orbital. Those are s, p, d, f, and this d orbital splits into 5 different degenerate orbitals. This d orbital splits into 5 different degenerate orbitals, right? Those are dxy and dyz, dzx and dx square y square and dz square, right? In these 5 orbitals, 3 orbitals are lies between the x and y and z axis, and 2 orbitals lies on the axis. For example, if you take this is x and y axis, right? This is x axis and this is y axis. So if you see dxy orbital, this dxy orbital lies between the x and y axis. Right? So the question is, the orbital lies between x and y axis is dxy orbital. So the correct answer is first option. Let's move on to the next question. So the question is, maximum number of electrons in main shell is. So each and every atom contain nucleus, right? That nucleus, around the nucleus there are main shells are present. If you see the atoms diagram, so the nucleus is present in center of the atom. So around the nucleus, the main shells are present in which the electrons are revolving around the nucleus. So these green color lines are represents the shells, right? So we know that electrons are present in the cells. They are revolving around the nucleus in these main shells. So how can we find how many number of electrons are present in particular cells? So this is the K shell, and this is L shell, and this is M cell. So each and every cell has represent with capital letters, right? So how can we know that how many electrons are present in particular cell? So there is a formula to calculate how many numbers of electrons present in different cells. That formula is 2n square. 2n square. By using this formula, we can find the number of electrons, the maximum number of electrons which are present in the different shells. So this n is principal quantum number, which is represents the shells number. Principal quantum number. So the formula for the maximum number of electrons which are present in the shells is 2n square. So the correct option is first option. Clear? Let's move on to the next question. So here the question is the maximum number of electrons that can accommodate in each orbital, right? So in previous question, this question has small difference. In previous question, they have asked maximum number of electrons that are present in shell, but here the maximum number of electrons that accommodate in each orbital, right? So each orbital contain only 2 electrons, For example, if S is orbital, so S contain only 1 orbital, that contain 2 only. So P has 3 orbitals. So each orbital contain 2 electrons. In that, total 6 electrons can accommodate in P orbital. Right? In that way, we can say that the single orbital, this one, the single orbital can accommodate with only 2 electrons, right? So the correct option is third option. I hope you understand well. Thank you very much.